Hi students, welcome back to my channel. Today let us learn a few NCERT questions on the chapter Atoms and Molecules. First question, in a reaction 5.3 gram of sodium carbonate reacts with 6 gram of acetic acid. The products were 2.2 gram of carbon dioxide and zero point 0.9 gram of water and 8.2 gram of sodium acetate. We have to show that these observations are in agreement with law of conservation of mass. So now what does law of conservation of mass state and who proposed it? It was proposed by Anton Lavoisier in the year 1789. So according to this, the statement goes, mass can neither be created nor be destroyed in a chemical reaction. Means very simple. What is the amount of the reactants that we take in a reaction, okay, and the amount of product that is obtained should be equal, and it is always true, it is always equal. Okay, so this is called as the law of conservation of mass. So now I've taken a basic example, a plus b giving rise to c. A and b are reactants and c is the product. So let's say 2 gram of reactant a, okay, and there are 3 grams of reactant b, which are in reacting in a vessel. So now how much of the reactants are being involved in the reaction? 5 grams. So now if 5 grams of A and B are reacting and there is C which is formed as product, and it is said that C must also be 5 gram, which is which holds good for this law, that is law of conservation of mass. Means whatever amount of reactants we are taking, utilizing in the reaction, the same amount of products must be formed. So this is according to the law of conservation of mass, which is proposed by Anton Lavoisier. However, there are many conditions for which this law is satisfied. Okay, for example, these reactions take place only in closed vessel, okay, wherein the pressure, temperature, all of this is optimized. Only then the law of conservation of mass is applicable. So now according to this chapter, we will always consider that we are going ahead with the law of conservation of mass. That's proving, and keeping that in mind, let's solve this problem. So the information is already being given to us, all the grams or amount of the reactants and products which are formed is being given to us. We only have to add them and check whether this law is applicable or not for this particular reaction. So how much of gram of sodium carbonate is given? He has given 5.3 gram of sodium carbonate and 6 gram of acetic acid. So totally it will be 11.3 gram of reactants. And how many grams of products are formed? 2.2 gram of carbon dioxide and zero point 0.9 gram of water and 8.2 gram of sodium acetate. So this will totally come up to, again if I add, I will get 11.3 gram. Okay, now, so is this reaction in agreement with law of conservation of mass? 100%, because 11.3 grams of reactants was utilized, and again we got 11.3 grams of products only, not less, neither more. So that's why this particular reaction, or this particular equation or reaction satisfies the law of conservation of mass. Okay, so now next let us go to the next question, second one. Hydrogen and oxygen combine in the ratio of 1 is to 8 by mass to form water. What mass of oxygen gas would be required to react completely with 3 grams of hydrogen gas? Okay, so first, as soon as I look at the reaction, it's very simple. It's a combination reaction, okay, wherein hydrogen reacts with oxygen to give rise to water. Okay, so hydrogen and oxygen combines to give rise to water. It's a combination reaction. And he has also mentioned that the ratio is 1 is to 8. Means 1 gram of hydrogen reacting with 8 gram of oxygen. So what will be the amount of water which will form according to law of conservation of mass? 9 grams. Because 1 plus 8 is 9. And this is the in accordance to the law of conservation of mass. Now, the second part of the question. What mass of oxygen gas would be required to react completely with 3 gram of hydrogen. So now he has given 3 gram, or he's taking 3 gram of hydrogen, and how much gram of oxygen will be required for complete reaction. So it's very simple, cross multiply. If I take the unknown as x, then 1 into x is equal to 3 into 8. So x will be equal to 3 into 8, that is 8 3s are 24 gram. Okay, so 24 gram of oxygen will be required to react completely with 3 gram of hydrogen gas. Okay, students, so it's very simple, cross multiplication. Then how much of water will be formed? Water will be 3 plus 24, that is 27 grams of water will be formed. So it's all these, the reactions are in accordance to law of conservation of mass. So now next question, let's go to the next one. How many atoms are present in H2S molecule? Okay, so now how many atoms means he is asking us to know, calculate the, or find out the atomicity, means how many atoms are there in a molecule. So now first one, H2S, right? So how many atoms of hydrogen are there? 2 atoms of hydrogen. And how many atoms of sulfur are there? 1 atom. So totally, what is the number of atoms participating or present in H2S? It's 3. So atomicity is 3. Okay, now just very simple, just go on adding the number of atoms. That's it. So now PO4. Now observe, P is how many atoms? 1 atom. And O, oxygen is O4, right? So 1 plus 4, 5 atoms are present in PO4, 3 minus. Now this 3 minus, 2 minus, all these are just the charge. Okay, they're nothing but the charge on the molecule, or charge on the atom. So charge you're not considering, students. Atomicity means, what's the definition? Total number of atoms that constitute a molecule is called as atomicity. So we are just focusing on the number of atoms and not on the charge or the ionic charge, okay, present on them. So now here, according to this, PO4 3 minus will be having how many atoms? 5 atoms. And H2S will be having 3 atoms. Now next question. Calculate the molecular masses of hydrogen, oxygen, methane, C2H6, C2H4, ammonia, and CH3OH. So now first let us understand what's meant by molecular mass. It's a sum of atomic mass of all atoms in a molecule. Means I just go on adding the atomic mass of all the atoms present in a particular molecule, and that will give me the molecular mass. Means it's the mass or weight of the entire molecule. So if I have to consider the weight of the entire molecule, what will it be? It will be the sum of the atomic mass of all the atoms present in them. So very simple example, let's take H2CO3. Now the criteria to solve this problem, these type of problems, is that you must be knowing the atomic mass, okay? So atomic mass of some of the common atoms you must be knowing, like hydrogen, carbon, oxygen, nitrogen, right? And also like elements like sodium, chlorine. So these are some of the elements which are repeatedly asked. And also if you check this textbook chapter also, these atoms are repeatedly, you're seeing them often in this chapter. Okay, but however, some of the atoms atomic mass will also be given to you in the examination. For example, something like zinc or aluminium. Okay, these are something which are like very rarely used in the chapter. So for them, it will be given for to you. But anyway, you must be having a little bit knowledge about the atomic mass. Okay, so now H2CO3. See, these three atoms are quite similar. I mean, sorry, quite familiar. I'm sorry. So hydrogen, what is the atomic mass of hydrogen? 1. Carbon is 12 and oxygen is 16. Right? So how many atoms of hydrogen are there? 2 into 1, 2, plus carbon is 1, 1 into 12, 12, plus how many atoms of oxygen are there? 3. 3 into 16, 48. So now if I have to add all of them, what will be the answer? 12 plus 2, 14, 14 plus 48. 8 plus 4, 12, 62, right? So 62 is the molecular mass of carbonic acid H2CO3. So that's the way we solve. Okay, students. So now let's go back and solve some of them, some of the questions. So now H2, very simple. Atomic mass of hydrogen is 1, and how many atoms of hydrogen are there? 2 atoms. So 2 into 1, 2. So 2 is going to be the molecular mass, and we are specifying their units also. It is atomic mass unit. Next, let's take another example. Oxygen. Oxygen, what's the atomic mass of oxygen? 16. And how many atoms are there? 2. So 16 twos are 32. 32 U is the molecular mass of oxygen. Right? Now, similarly, we have um, methane. Let's say methane. So now for methane, how many atoms of carbon are there? 1 into 12 plus how many atoms of hydrogen are there? 4 into 1. So 12 plus 4, 16U. Right? So for methane, what's the atomic mass? It's going to be 16. Next, let's solve C2H4. It's a very similar. They're all again hydrocarbons. So C2H4, 2 into 12 plus 4 into 1. 12 2 is 24 plus 4, 28. 28U is the answer, molecular mass of C2H4. Okay, so like this, we can go on solving. Now let's take one more example, ammonia. Let's solve ammonia. Ammonia, what's the molecular mass of atomic mass of nitrogen? It's 14 plus 3 into 1. 14 plus 3, 17U. So the molecular mass of ammonia is 17. Okay, so that means that one molecule of ammonia weighs 17 gram, 17U. So it's like that. Okay, students. So like this, we can solve many problems. So one more, let's take one more, last one. CH3OH. Carbon is 12. 12 into 1, 12. Plus hydrogen, let's add them. 3 plus 1, 4. 4 into 1, 4 plus 16. 16 plus 16, 32. Right? Correct. Okay, so like this is how we calculate the molecular mass of different compounds. Okay, now next let's go to the next question. Calculate the formula unit mass of zinc oxide, sodium oxide and potassium carbonate. See, as I already told you, they have given the information data. What are they given? They've given us the atomic mass of these compounds: zinc, sodium, potassium, carbon and oxygen. So most of the times they're giving the atomic mass. Okay, but still as students, your duty to learn the atomic mass of some of the elements. So now let's solve. So now let me also tell you, students, the difference between formula unit mass and molecular mass. For molecular mass, we're always considering for covalent compounds. Okay, means a compound which is or a molecule which is formed by sharing of electrons, covalency. Only for such compounds we give them the name molecular mass. So if you look at these examples, okay, the previous ones: hydrogen, oxygen, methane, ethane, ammonia, methanol, again so many other compounds. So in all of them, what is the common thing that we can observe? They're all non-metals. So whenever bonds are formed in between non-metals, they are usually called as the covalent bonds. Means here the electrons are uh, equally shared. Okay, just like you have a joint account, right? So just like that, the electrons are equally shared. But when we talk about um, formula unit mass, so it's something different. How is it different? Here we are talking about ionic compounds. Ionic compounds means in your future class you'll be learning more about ionic compounds. Just for now, understand that here there is transfer of electrons. It's not sharing of electrons. It's just like that one of the atom is giving away all its electrons and the other one is accepting. So that kind of an arrangement of electrons is called as ionic bonds or ionic compounds, gives us to ionic compounds. That is what we can see here. Usually a reaction, usually a bond formed between a metal and a non-metal. See now, zinc oxide, zinc is a metal, oxygen is non-metal. Sodium oxide, sodium metal, oxygen non-metal. Potassium carbonate, potassium is metal, carbonate is a non-metallic ion, right? So whenever this type of bond is formed between metal and non-metal, it's called as non I'm sorry, ionic compounds, ionic bond. Okay, so whenever we're dealing with ionic bonds, we usually refer to this type of a um, you know indication, that it's a formula unit mass. Okay, now let's solve one of the questions. Zinc oxide. So what's the number of atoms of zinc present? 1. And what's the atomic mass of zinc? 65. Plus how many atoms of oxygen is present? 1 into what's the atomic mass of oxygen? 16. So now 65 plus 16, 81. 81 U is the formula unit mass of zinc oxide. Okay, it's just like that. We can solve for the other problems also. Let's take one more example. Na2O. Sodium, what? How many atoms of sodium are there? 2 into what's the atomic mass of sodium? 23. Plus 1 atom of oxygen is there and 16 is the atomic mass of oxygen. Now 46 plus 16. 62. 62 U is the atomic mass of sodium oxide, Na2O. Okay, so like this we can solve many more problems. So I hope this video was helpful to you. Kindly subscribe. Thank you.